Hey, this is Mr. Sullivan. We are on page 109. Today we're going to be doing topic 2. We're going to start it. We're going to do lesson 1. First lesson is called Blame It on the Rain. And we are going to actually start on page 111. Now, page 111 describes a situation where we're going to make some gutters. So I want to make sure we understand this. It says a sheet of metal. So a sheet of metal that starts like this. But then they're going to fold the metal so that we have two equal sides and a bottom width. Okay, so we have a height and we have a width. We don't have anything else. The water would run through here. All right, your picture's on page 110, for example. All right, so we want to determine the width for each of the given heights. All right, so let's take a look here. So if I had this and my height was 0 and my height was 0, it says we have 8.5 total feet of this, right? So if I'm laying it out, I know that I have 0, I'm taking 0 away, and I'm taking 0 away. What's left? I have 8.5 feet left. So I'm still going to have 8.5 feet left for my drain there. All right? You can think about it. I'm starting with 8.5, and how much am I taking away? Well, I'm going to take away the same on each side, aren't I? So in this case, I'm taking away 0.5 on each side. So I'm doing it twice. So in this situation, I'm going to do 8.5 minus twice 0.5. All right. And when we do that math, if you need a calculator, go ahead. But this is 2 times 0.5. That's 1. So 8.5 minus 1 is 7.5. We go do it again down here. I would have 8.5 minus twice of 1.25. And when we got that, we would get 6. So I would like you to complete this as best you can. Pause the video and complete it. And I think it'd be really helpful if you wrote this out on the side for just a minute. So go ahead, pause that video right now and fill the table out. Great, so I got 8.5, 7.5, 6, 5.5, 5, 3.5, 2.5, 2, and not possible. All right, one of the questions at the beginning, it said, write a function for the bottom width given the height h. So if you look at this, all of the time throughout here, our height was this in the parentheses, right? And it changed. It varied every time. So if our height is h, we would plug that in over here, 8.5 minus 2 times h. That right there is going to be the width of the drain. We have our height, and now we have our width. Down here it asks, the engineer needs to identify the measurements that allow the most water to flow through the drain. What do we need to calculate? So if I need the most water to flow through here, I don't really need just height and width. I need area, right? I need to find the area of the drain. Whoa, I'm sorry. And what do we need to calculate that? We're going to calculate that with the height, which we know is h, and times the width. And do we know the width? Yes, we do. We have an expression for 8.5 minus 2h. Okay, so we're going to calculate the area using the height and the width. All right, so over here it says, describe how to determine the cross-sectional area of the drain. We're on page 112. So the height times the width. How am I going to find the area of that? We're just going to multiply those together, right? So it's going to be height times width. Let's keep going. It says predict and describe the drain with a maximum cross section. So is it going to be short but wide? Is it going to be tall but skinny? You know, what do you think they would be? Take a second, pause the video, and describe how you think this cross section will look like for the maximum area. So I don't know what you said, but I think a square is going to be the maximum area we get through here. It optimizes everything. We're going to have the same dimensions on all 4 sides. Number 4, it says define a function. So we want to find a area function comprised of the area of the drain with the height, and let's take a look. So we knew we had to multiply by the height, which is h, and we're going to multiply that by the width. And we know our width was 8.5 minus 2h. All right, so now we have our height and our width. And it says use some technology to graph it. So you need a calculator for this. So we're going to open up our calculator. I'll pull this over here. And I'm sure this is the first time for a lot of you using a calculator, and that's fine. You need one of these 84s. It's going to graph. So right up here, we're going to put in y equals. If there's anything in there, you can clear it out by pressing the clear button, and I would clear everything out. Next thing I look at is these plot buttons. If any of them are highlighted, you can go up to it. If it's highlighted black, you want to go up and highlight it, press enter, and make sure it's off. Now we're going to put in this equation. Now you can't put h in, you have to put x. So x is right here, so I have x, parentheses, 8.5 minus 2x. And then I need to end the parentheses. All right, now I'm going to go to graph. And what I'd like to do is make sure this graph is kind of nice and neat. So I want to zoom to a standard graph. So I'm going to zoom standard 6. All right, and that's what a standard graph would look like. It has 10 units this way, 10 down, 10 left, 10 up. But you'll notice our graph doesn't do that, does it? So we can change this. I'm going to change my window. I'm going to go to window, and I'm going to change it to this. So these are my x values. So my lowest x is 0. So my x min, my lowest x is 0. My highest x, my maximum x is 5. All right, now I'm going to go to my y's. My lowest y is 0, and my highest y is 10, which I have. Now I can graph it. Now we can see a few things. It looks like 1, 2, 3, 4. Right after 4, it's going to hit somewhere in here. I'm going to put that down there. All right, let's see. Somewhere up in here, it looks like that's 9. Somewhere around 9 is my middle one, and it's somewhere around 2. All right. And it goes through 0, 0. And we have a nice parabola formed right there. All right, that's just done all on your calculator. When it says sketch, it doesn't have to be perfect, okay? All right, let's go to the next one. Now we're going to actually use this, and we're going to use our technology to find some things. What is the maximum area? So let's go back to this graph. So this is height, right, h, and this is area. So our area is a y value. So our maximum is going to be right at the top here, and we can calculate that on our calculator. Anytime you want to calculate something on the calculator graph screen, you're going to do this. It's in blue, therefore I have to press second calc. Now, which one of these do you think is going to help me find the maximum area? Well, number 4 says max. So I'm going to hit max. Now it has some questions on there. It'll say left bound and right bound. Now I'm going to show you on my screen here. So I'm going to move my cursor to the left of where the highest point is. All right, so I'm going to move it to the left. So I think my highest point is right about there. I'm going to go to the left. Doesn't matter how many times, as long as you're to the left of it. And then I press enter, and then it comes up as a right bound. So then I'm going to go to the right of my highest point. All right, that's to the right of my highest point. And it says, do you want to guess? I never really want to guess. I know that it's going to look between these two things for the highest possible value of y. So let's press enter, and let's write that down. So that is going to be 2.125 and 9.0. Let's do that. So that point is 2.125 and 9.03, it looked like. All right. Okay, good. So now we know what is the maximum area? 9.03 feet squared. Is it important to include that label? Absolutely. All right. All right, now you're going to identify and label the intercepts. So let's go back. We're going to identify the intercepts. Well, there's a very easy intercept, so I'm going to press quit, just graph it again, sorry. This one goes through 0, 0. So intercepts, if you recall, intercepts are when we have zeros. So let's find the x-intercepts. That's when my y value is 0. And looks like there's 2 of them. And let's find our y-intercept. That's when the x value is 0. So if we look on this graph, it's very easy to see that this is 0, 0, right? And I could go to my table, second table, go up to 0 and 0, 0. So that is an x-intercept, 0, 0, and a y-intercept, isn't it? All right. But we also need to find our other intercept right here. So how could I find that? I'm going to go again and calculate. So I need a second calc, and I want to find a 0. It's called a 0. So I'm going to press 0. All right, and it's the same thing, left bound and right bound. So I'm going to go over to my 0. All right, right about there. I'm going to go to the left of it, press enter. I'm going to go to the right of it. I'll know I'm to the right because my y values will be negative. That's the right of the 0. And I'm going to press enter, 4.25. So my other 0 is 4.25. So that means at 4.25 feet, I have 0 area, right? And at 0 height, I have 0 area. That should make some sense, right? All right, now it says identify and label the equation of the axis of symmetry. Let's go back over there. So the axis of symmetry is the line that cuts it in symmetric pieces. So right here, through the vertex, is our axis of symmetry. Now what we didn't understand at the time, but we probably should now, is that the x value of our vertex is going to be that axis of symmetry. So the axis of symmetry is 2.125 feet. So when our height is 2.125, that means we are going to have the maximum area. All right? So we have our equation, x equals 2.125. That will be our axis of symmetry. Then it says draw and label the drain with the greatest. So we now know that we have a 2.125 height and a 2.125 width. And that should give us our greatest of 9.03125, or whatever we found there, right? Number 9. In this problem, we built a new function. So we had a variable, and then we found a new expression. It says, what is the first factor? So our first factor is h. And what family of function does it belong to? Well, it's a power of 1. Therefore, it is a linear equation. What's the second variable? 8.5. Or excuse me, our second factor was 8.5 minus 2h. It is also linear because it has an exponent of 1. Its degree, the highest degree, is 1. And what does it produce when we multiply those together? Well, when we multiply them together, I'm going to get 8.5h minus 2h squared. And that squared means the result is quadratic because I have an exponent of 2. All right, very nice. All right, so I want you to go to page 117. Page 117 is going to be your homework. Just number 1, A, B, C, and D. I want to give you a clue here. It might be nice for you to draw over here. Draw what you're talking about, label it. See if it can help you find things over here on this. All right? All right, best of luck. Remember, it's really important that you ask for help as much as you possibly can. Okay, good luck on the master check.